So here we are going to have today inflection point. So x equals c is an inflection point. So that is an inflection point if you have the following condition. Condition number one, the second derivative at c is 0 or does not exist. That's our second derivative. And the concavity change means here's your c, before c concave up and after c concave down, means your second derivative greater than 0 means you concave up. If the second derivative less than 0, then concave down. If I look to the before c, if it's the second derivative less than 0, negative, then it's concave down and concave up. So what happened here, the sign of your second derivative, it change. That is the sign of my second derivative, sign of second derivative change. So here from positive, as you can see, and here to negative, just write negative sign here, and here positive, excuse me, and here negative. So the sign of concavity here, or the sign of second derivative, keep changing from negative to positive, or positive to negative, or concave up to concave down. And what is the condition number 3? Condition number 3, your x equals c must be inside the domain, must be inside the domain. All right, so must be inside the domain. All right, so let me give you some example here for this definition here. I need to figure out two things today. What is I need to find, that's our goal for today, find the inflection point. I need to find the inflection point. So that is I need to get that, and also that is a. B, I need to find the interval. I need to find the interval where f is concave up, where f is concave up and concave down, concave up and concave down. So let me give you one example, easy example first, in order to get the whole thing. F of x equal here x cubed minus 12 x squared plus 20, 1x plus 8. Here is your first derivative given. After I simplify the first derivative, you have 3x squared minus 24x plus 21. That is equation 1, that is equation 2. And the second derivative here is given to you, which is 6x minus 24. So now I need to, what is the goal? Our goal here to find the critical, what's called the inflection point. So x equal inflection point. So your second derivative could be 0 or does not exist. So where is my second derivative? It's here. So what do you have for second derivative? It's polynomial of degree 1. The highest power for x is 1. So this polynomial exists for any value of x, for any value of x. So here, if you look to the domain of your f of x, the domain here always for f of x. Here, this f of x here, what you have polynomial of degree 3. So the domain should be all real numbers, right? So if you take any number from these real numbers, you put in second derivative, always your second derivative you have exist, means you are going to get a value for second derivative. When your second derivative at 0, you get value. At 1, you get another value, and so on and so forth. So there is no value for x. If I put it in my second derivative, your second derivative does not exist, or you have error when I use technology. So because of that, condition number 1, I have to take the second derivative, equate that to 0. So go ahead and find the second derivative to 0. So what do you have? You have 6x minus 24. That is my second derivative, equate that to 0. If I solve that, you have your 6x equal 24. So what is your x? Your x equal 4. Your x equal 4, right? Your x equal 4. So now, that is where your second derivative, the condition number 1, second derivative is 0. So x equal 4 here, that is make my derivative is 0. So that is condition number 1. Condition number 2, I have to check concavity. Here's your 4, right? I have to check the sign of your second derivative. So what happened for the sign before, second derivative, before and after? So now take any number you wish before 4. Before 4, say for example, easy, take x equals 0. So what is your second derivative? Your second derivative here is, is equal 6x minus 24. 6x minus 24. So if I replace x by 0, what did you get? You get negative numbers. So the sign here is negative. If you take x equal 1 or 2 or 3, you will get second derivative is negative. So now if I take x equal 5, it's any number here after 4, just 5, then what did you get? You get here positive. So as you can see, if it's negative, then it's concave down. If your second derivative negative, means the graph is concave down. If the second derivative positive, then the graph is concave up. So condition number 2 here satisfy, means your concavity changed from concave down to concave up. That is condition. What is last condition? Last condition number 3 is x equal 4 inside the domain. Inside the domain, yes. What is the domain here? The domain here is all real numbers. All of them. So because 4 is one of these real number, so the 3 condition here satisfy. Second derivative is 0. Concavity change around C, and C here must be inside the domain. Because of that, yes, we have x equal 4 is inflection point. So what is the inflection point? The inflection point always, that is, you must get f of 4. So that is your y. When x equal 4, what is your y? So I have to go back to equation 1. Equation 1, so you have 4 cube, right, minus 12, 4 square, plus 21, x, which is 4, plus 8. So that is, you have to use technology for this number here. And then in order to get this one here, I don't have my technology with me, but whatever it is in the number, so the value here should be 4, and here f at 4, this number that you are getting, this one we call it inflection point. So the inflection point, that is your x and y. Inflection point, that is your x and y. Okay, guys, so that is our example here, how to get inflection point. So let me go and find another example here to apply the inflection point. So here is in one example in my sheet. That's example number 2. So before I finish this one here, I need to get the interval. I need to get the interval where of f is concave up. Where is f? The interval, the graph is concave up. So if I look to the inflection point, so concave up starts from 4 here. That's 4 to plus infinity. From 4 to plus infinity, that is your, so the interval is concave up from 4 to plus infinity, and the interval concave down, that is, it starts from minus infinity to 4. So what you have here, minus infinity to 4, that is where you have your the interval f is concave up and concave down. So the inflection point here, it means you have is help us to find where is the interval where f is concave up and concave down. Alright, guys, so here, just in terms of graph here, inflection point means if the graph is concave up here, concave up, then after that it will be concave down, right? Or it might be concave down here. It's sorry, concave up. So or maybe here just to try to concave down, and then if that is inflection point, then the other one will be concave up like this, concave down to concave up, and here concave up to concave down, and so on and so forth. But that is the interval. So inflection point help us to find where is the graph concave up and concave down. Okay, guys, so let me give you another example here where you have if the interval here, I need to find the inflection point. So here you have f of x equal ln x over x, So now what is the question? I need to find the inflection point, and also I need to find where is the interval. You have a graph is concave up and concave down. All right, so let me give you the first derivative here. That is how to get the derivative, quotient rule, ln x over x, quotient rule. So let me give you the derivative here, 1 minus ln x over x squared. All right, so that is equation 1, that is equation 2. Second derivative here is, after I simplify, you have 2 ln x minus 3 over x cube, all right? So that is number 3, 2 ln x minus 3 over x cube. So that is your second derivative. So now I need to find the inflection point. Number 2, I need to find the interval where f is concave up and f is concave down. So now let me ask you, what is the domain? What is the domain for this function here? I said previous one class, if you have log x always you take whatever inside your x here should be greater than 0. We mentioned log 0 we have error, log negative number you have error, which means if you take log positive number is okay, you don't have error when I use technology. So the domain should be whatever inside log x greater than 0, right? So x greater than 0 because I cannot have x negative, and here you have a fraction, so x in a way cannot be 0. But when I say x non-zero, could be negative, it could be positive, but I cannot take -1 because log negative number you have what? You have error, so which means it's not in the domain. So that is our domain, x greater than 0. I could write it like this, from 0 to plus infinity. All right, so now what is our goal? I need to find the inflection point. I need to find the inflection point. How to find the inflection point? I take a look to the derivative here. What is my derivative? Here is the derivative, 2 ln x minus 3 over x cubed. What is your x? What is the domain x greater than 0? So if you take any x greater than 0, any positive x here, if I put it here, you will see your second derivative always exists. You get a value for second derivative. Exist means you are able to get value when say you replace x by 1, or replace x by 2, or by 3. Every time when you replace, you get one value. So there is no value x. If I put it here, my derivative does not exist. The only way here, I cannot have x equals 0, and I cannot have x negative, and that is not in the domain. So now I have to equate second derivative to 0, and now I need to solve this. So what you have 2 ln x minus 3 over x cubed equals 0. I said here, recall guys, recall, if you have a over b equals 0, this one here means your a is 0, right? And your b one, your b cannot be 0. Why can your b cannot be 0? Because b I cannot divide by 0. So now here, take whatever I have up, which is 2 ln x minus 3 equals 0. Then I have to solve this one here. So what do you have? You have 2 ln x equal 3. Then I have to divide by 2. So you have ln x equal 2/3. And then I need to solve this one here for x. So recall here, if you have log b of x equal y, what is equivalent to this? It will be b to the power y, equal to whatever inside here, which is x. So b to the power y equal whatever inside here, which is x. So now what you have here, ln x equal 2/3, right? So what do you have? This one, it's nothing but is log e of x equal 2/3. What is equivalent here? What is your e? That is your b. What is your y? That is 2/3. So you have e, your x is what? E to the power 2/3. E to the power 2/3. That is your x, right? If you look to this one, if you try to use technology to get the number here, you will see this number here, it's almost, right? So if you try to look for this number here, you will find it's a positive number. It's a positive number. So that is condition number 1, which is I took the second derivative, equate that to 0, and then I try to solve this one here. So here I think I did, look what you have here, that is 3/2. So here it should be 3 divided by 2 here. So here, look what you have, I took 3 to the other side, then you have 3/2. And then here I switch 3/2, sorry for this, 3/2, and then here you have 3/2, and then here you have 3/2. Okay, so you have your x almost, if I use technology for this, you get almost 4.5. So 4.5, that is positive number. All right, so is this one inside the domain? Yes. What is your domain? X equal greater than 0. So what is the condition for inflection point? I have 3 conditions. Condition number 1, your second derivative is 0. So that is what I did. Your second derivative is 0. I equate the derivative to 0, and then I solve, I get 4.5. Then condition number 2, I have to check if this number inside the domain, what is the domain? X greater than 0. So yes, 4.5, it's a positive number. So condition this satisfy. What is the last condition? I have to check the sign of your second derivative. What happened for 4.5 here? And here you have 0, the domain x start from 0, after 0, and due to plus infinity. So now I have to check the sign before 4.5 and the sign for my second derivative after 4.5. So here, what is your second derivative? Your second derivative here, just copy that. Your second derivative here is 2 ln x minus 3 over x cubed, right? X cubed. What do you know about x? It's positive. Your x here is positive. So I'm not worried about this term because it's always positive, because x is a positive number. So I'm worried about this term here, whatever I have up. So now, for make our life easy, take x equal 1. Take x equal 1, because when I take x equal 1, so what do you have? You will have, you go ahead and find the second derivative at 1. It will be 2 ln 1 minus 3 over 1 cubed. This one is 0, ln 1 or log 1 is 0. So what did you get? You get here negative 3. So this one is negative sign here, less than 0, which means the graph is concave down. The graph is concave down. So now take x equal 5, right? You take x equal 5, or take a number like, for example, here x equal e to the power 3. E to the power 3. What is e to the power 3? It's 2.7 to the power 3 to the power 3. The reason for that, why I take e to the power 3, because I know ln, so look what you have, second derivative at e to the power 3. It's a positive number, so you have 2 ln e to the power 3 minus 3 over e to the power 3, right? E to the power 3 to the power 3. So this one is positive, I'm not worried about it. So what is the number here? 3 here, you have 3. I can put it in front here, in front log. So 3 multiplied by 2, you get here 6, right? So you get 6 here and minus 3, right guys? Okay guys, so here you can 2 to the power 6, it will be 6 multiplied by ln e, which is 1 minus 3 over positive number 3 multiplied by 3 here, right? So you have 3 multiplied by 3, so you get here, so this one here is positive number. So what did you get? You get something positive in a way, or just replace x by 5, and then you have to use technology to compute second derivative at 5. You'll see it's a positive here, positive sign. I write positive sign here, positive sign. So the graph is concave up. So here is the condition number 3, the concavity change from concave down to concave up. And then the second, so that is condition concavity change, or the sign of your second derivative change from negative to positive. And then I have x 4.5, that is where your second derivative is 0. So your second derivative is 0, I got 4.5, and then I have to check inside the domain, and last one, concavity change. So what is the conclusion? The conclusion here is x equal 4.5 is inflection point, but I have to go ahead and figure out x equal 4f at 4.5. Why? Because you must have x and y. X and y, when x equal 4.5, what is your y? Your y here is the value f at 4.5. So you have to go back to equation 1, and then you have ln e to the power 4.5, and here divided by 4.5. You can use technology for this, whatever the number, that is your inflection point. So your inflection point 4.5 and the value f at 4.5, you have to get the number. So that is our inflection point. So now I need to figure out where is the interval is concave up, what is the interval is concave up, and where is the interval is concave down. If you look to the here, look what you have, start after 0 to 4.5, that is where the graph is concave down. Your second derivative negative, so from 0 to 4.5. So I should write from concave down from 0 to 4.5, and from 4.5 to plus infinity, that is where the graph is concave up. So here is concave up and here is concave down. Okay, so that is the question. I answered the question. For this example, I need to find the inflection point, and also I need to find the interval where f is concave up and concave down. All right, so let me give you another example here, then I can wrap here. Example number 3 about inflection point. So here I have here, you have f of x here. Just let me write f of x equal x square e to the 1 negative x, x square e to the 1 negative x. So let me give you the first derivative, and also I give you the second derivative, so that it will be easy. Okay, so here x square multiplied by e to the 1 negative x, you must apply product rule to get the the derivative. Just apply product rule. So let me give you the derivative here. It will be x2 minus x e to the 1 negative x. So that is equation 1, that is equation 2. What is the second derivative? The second derivative here is just it will be x square minus 4x plus 2 multiplied by e to the 1 negative x, and that is equation 3. So what is the question? I need to find the inflection point. That is number 1. I need to find the inflection point. Also I need to find interval where concave up and the concave down. So that is A, I need the inflection point. B, the interval where f is concave up and concave down. Okay, so here apply product rule and then simplify, you get this one. Then apply product rule to get numbers second derivative. Okay, so now I need to find the inflection point. What is the inflection point? First, let us find the domain. What is the domain here? The domain here is all real numbers. Why? Because if I look to here, what do you have? X squared. X squared is polynomial. The domain of any polynomial should be all real numbers. That is exponential. Exponential here also is all real numbers. So the overlap between entire real number, all real numbers, it will be the same. So the domain here should be all real numbers. Now, when I look to the second derivative, you have here polynomial, this one polynomial, and this one exponential. So the second derivative always exists. If you have polynomial, means it's no problems, nice and smooth. So if you take x, any real number, I put it here, always you'll figure out that there is a value for my second derivative. So then I have to take the second derivative. I need to find the critical point. So inflection point. So I have to take the second derivative equated to 0. So what is my second derivative here? So just copy that. It will be x square minus 4x plus 2 multiplied by e to the power negative x, and that is equal 0. That's my second derivative. That is our second derivative. I equate that to 0, right? So now, what do you know about e to the 1 negative x? If you look to my previous classes or lectures, you have e to the power x. Here it's always positive for any real number x, all right? If you take again here, take x equals 0, you find it's a positive. If you take x equal 1, a positive, x equal negative 1. So here, when I take x equals 0, you have e to the power 0 here, which is e to the power 0, which is 1. You take x equal 1, you have e to the power negative 1. Just replace x by 1, right? So you have 1 over e, which is 1 over 2.7, positive. When you take x equal negative 1, you have e to the power negative 1. So you have e to the power 1, which is 2.7, is positive. So any exponential term here is always positive. So now this one, it's a positive non-zero, so this bracket must be 0. So what do you have? You have x squared plus minus 4x plus 2 equals 0. Use quadratic formula in order to solve this. Use quadratic formula over 2a, right? So that is give you 2 solutions. We cannot factor this one here because here 2 and here 4. So 2, how to get 2? 2 multiplied by 1. So 2 multiplied by 1, if I add those, you get 3, not 4. If I subtract those, you get 1. So here I cannot factor, so I have to use quadratic formula. So what is your a? 1. What is your b here? Negative 4. What is your c? 2. So what is the solution then? Negative 4 plus or minus b square, which is negative 4 square, minus 4a, which is 1, c, which is 2 over 2a. What is a? Is 1. If I simplify this, you get 4 plus or minus 16 minus 8 over 2. So that is, will be 4 plus or minus 8 over 2. So that is 4 plus or minus 2 multiplied by 4 over 2. Right? So what you have 4 plus or minus square root of 2, square root of 4 divided by 2. So what is square root of 4? Is 2. So you get 4 plus or minus 2, square root of 2 over 2. If you simplify that, you have 2 plus or minus square root of 2, right? So here you get two numbers. Well, the first one is 2 plus square root of 2. The other one, 2 minus square root of 2. Then you have to use technology to get the number here, those two numbers, in order to solve. So here you get 1.6 and the other one 3.4, right? 3.4 almost. Here I'm just around them. You have 0.6, 3.4. So you have two numbers here. Is this one inside the domain? Yes. What is the domain? The domain all real numbers. The domain should be all real numbers. So here 0.6 is okay, or just go ahead and find 0.6. So that is equation 1. Equation 1. What do you have for equation 1? You have x squared. Your f of x here equal x squared e to the power negative x. So if I need to get f 0.6, so it will be 0.6 squared e to the power negative 0.6. So here just go ahead and find the number here, whatever it is. And here f as 3.4, it will be 3.4 squared e to the power negative 3.4. You have to use technology to get the number here, whatever it is. It will be finite numbers, means your 0.6 inside the domain, 3.4 inside the domain. Okay, so now what is the last condition? I have 3 conditions to say they are inflection point. I have 2 inflection point here, but before I say yes, they are inflection point, I have to I figure out second derivative is 0. I get 2 number, and then condition number 2, I have to check if they are inside the domain. Condition number 3, I have to check concavity. So here 0.6 and here 3.4, and then I have to check the sign of my second derivative, the sign of my second derivative, right? So what is your second derivative? Your second derivative x, it will be, right, I'm just trying to x squared minus 4x plus 2 e to the power negative x, right? E to the power negative x. So now what about this term here? Just let me put the red here. This term, it's always positive. I need to look for the sign of second derivative. The sign, I don't care about the value, but I care about the sign, if it's a positive or negative. So this one here, it's always positive, so I should worry about this term, right? So now if I take here x equals 0, very easy. If I replace x by 0 here, then you get 0, 0, you get 2, which is positive. This one here, I'm not worried about it, so 2 positive. So this one here, it's a positive, so I write the sign here is positive. So which means the graph is concave up here, right? So between 0.6 to 3.4, take x equal 1. If I put it here, x equal 1, you get 1 minus 4 plus 2, right? 1 minus 4 plus 2. So 1 plus 2 gets 3 minus 4. You have negative. This one here positive, no worries. So what did you get? You get negative. So which means it's a negative sign here. And then the graph here is concave down, and here concave up. And what is the last one here? Take x equal 4. Take x equal 4. So if you have 4 here, what did you get when x equal 4? Your second derivative at 4, what did you have? You get 16 minus 16 plus 2. And here you get negative 4, which is positive. So here 16 cancel with 16. You get 2, which is positive, e to the power. So here you get positive 1 here. So the sign here, I write positive, as you can see, plus, meaning the graph is concave up. All right, concave up. So now, as you can see, concavity change from concave down, before 0.6, to concave up to concave down, and from concave down to concave up. So now, how many inflection point I have? I have 2 inflection point. So 0.6 is the inflection point. So I have to get the value of 0.6. You have to use technology to get this one. So that is inflection point, right? Inflection point. And also 3.4, and here f at 3.4. That is our second inflection point. So now, in order to finish, I need to get, where is the graph is concave up? Where is the graph concave down? Concave up, start the domain from minus infinity to 0.6. So minus infinity concave up, minus infinity to 0.6. Or what is the second interval? Concave up. Look what you have, 3.4 to plus infinity, 3.4 to plus infinity. So you have 3.4 to plus infinity. Where is the graph is concave down? The graph is concave down. If you have here negative sign, the sign of your second derivative is negative, means concave down, should be between 0.6 and 3.4. 3.4. All right, so that is where the graph is concave up and the graph is concave down. Okay, guys. So here, so what is the why is useful today to spend time for inflection point? Because it helps us for two things. First, it can help us to find where is the graph is concave up and concave down. That is, try to find the interval where f is concave up and f is concave down. The second thing here is I'm going to show you use all this information to sketch the graph, because before this point the graph could be concave up or concave down. After this point the concavity is going to change. So that is help us to sketch the graph when we need to do so. Okay. So okay, guys. So here I think I will stop here. That is a definition or the concept of inflection point. Thank you.